So hi, everyone. First of all, I wanted to thank Danske Bank for organizing such a great event, so many tech enthusiasts here. And I just wanted to measure temperature of the room a little bit. So how many of you here are actually building AI applications, like coding day to day and deploying some cool stuff? Okay, so not that many, maybe, actually, so which is cool. So my talk will be a little bit higher level than others, so it will not have any specific use case. It's more of a about the trends and what I believe is the future for agentic applications and how I think the industry will evolve through time. So it's called Hidden Challenges of Agentic Systems, but I was rebuilding the talk little by little, and now it's more about present and future and the trends rather than challenges, even though there are a lot of challenges, and I will also talk about. So a little bit of my history, as mentioned, 9 years, 8 to 9 years in machine learning, and fun fact is that I actually got introduced to machine learning and data science in Danske Bank around 8 years ago, and it kind of kicked off this entire journey from machine learning engineer to data engineer to finally machine learning operations engineer, where I was focusing more and more on infrastructure, and then eventually a Neptune AI chief product officer, where we kind of were building infrastructure for teams that are building their own machine learning models. And it was a very impactful journey for me there, because I also had a chance to very closely collaborate with some of the biggest AI labs in the world. And now I'm kind of doing machine learning on my own in SwirlAI. So we are consulting companies, we are building, and we are educating at the same time. So first of all, I wanted to acknowledge how far the industry has moved in the last 2 years of GenAI applications. So we have moved from a very simple large language model applications, where we're using mostly a single, very maybe sometimes complex prompt to get an answer through an LLM. And now we moved to something more and more complex, which is defined and called agentic system in our industry. And it has multiple flavors to it, but in general, at least today, most of them are agentic flows that perform certain actions via different large language model calls or other GenAI model calls. So let's not stick to large language models only. Multimodality is becoming a big thing, but we are introducing a lot of complicated elements to the system, like database queries, tool usages for web search, for performing actions in internal systems, so that the agentic system can actually interact with the environment that it is operating in. So we spoke about a lot about already today about RAG and different kinds of systems that utilize external data for agentic applications. But the most recent maybe evolvement of retrieval augmented generation systems, agentic RAG, is one of these agentic systems that we are talking about today. And it is a little bit more complex, and I think in CyberCare presentation, we actually had a few glimpses in what that actually is. So it's not only just retrieving data from your data sources, but also then piping the information all around, updating the state of the system, and then double-checking with other LLMs or other agents to see if the answers are actually good enough for the chat interface to return to the user. And then we do some loops to double check that. We also introduce some agency into the LLM system to allow it to choose which data sources to query from, and similar. Now, what is important here is that this kind of system, either it could be agentic RAG or simple RAG, or I think there are at least 5 other RAG names in the industry flying around. They are all not really autonomous, right? Because we define the system in how it operates. We draw the topology, how we connect the nodes in the system, so that they actually produce an output which we desire to be produced. So we kind of tell them what our end goal of the system state should be, and then we give some agency for the system itself to arrive to the state that we want to achieve. Now, even these kind of relatively simple systems do have quite a lot of complexity and challenges behind them. And I tried in this specific slide to draw a agentic system hierarchy of needs, while going from a product which is very simple, MVP-like, to something that can actually be moved to production. So I tried to use terms that represent how you would launch startups and products in startup world. So I started with POC. And for POC, to build a POC, it is it's not very easy, but it is already, the process from a developer's perspective is already covered by foundation model providers that kind of expose a model to you, and then you can start tinkering with it, and you can create something useful very quickly, usually in hours rather than days. But then we want to move the product to the next stage. I called it MVP, so minimal viable product, so something that you can actually expose to a user and test it out. So then we kind of need to add additional elements to the system, and data storage is one of the elements that was already talked about. So retrieval augmented generation systems require a lot of different data storage elements in your agentic system. Then you add orchestration on top of it. And Danske Bank's talk, by the way, very nicely represented what a orchestration framework is, because the person presenting actually introduced a not agentic, but large language model orchestrator into Danske, so they rebuilt it from scratch. So the next stage is once you want to move the product to actually beta stage, where you want to expose it to a larger set of customers, you need some even additional complexity in your system. And here I listed model routing and large language model observability. If you have tried building a machine learning system which to some extent requires some scale, so if you have quite large amount of customers using your product, you might notice that there are different kinds of problems popping up, like rate limits reached of your cloud provider, or some models not returning properly structured outputs anymore. And in general, just observing your system and understanding what users are actually doing and what your models are actually doing. So removing that black box from the large language model itself. So that's where large language model observability comes in. And the next stage, general availability. If you want to properly launch your product and not go bankrupt in the first days, you need to avoid disasters. And that's what you do by evaluating your systems. So separate evaluation frameworks, separate security frameworks. And security can mean multiple things, like introducing guardrails into your system, or doing red teaming on your system, trying to jailbreak your models and the system outputs, and similar. And then there are some additional, I would say, cherries on top that you can add. So I listed memory, but there are a lot more stuff to it. Now, a good thing about all of this is that large language model industry is so large, and so the market is so hot that we really have quite a lot of companies dealing in this space. So you can just go on and cherry pick a tool, and it will solve your problem to some extent. And myself, as a product person, I was doing product for at least 2 years in Neptune AI. I kind of did my market research, and this is just, I don't know, maybe 40% of the players in the market, probably a lot less than 40%. But it is nice to see that the companies, the infrastructure companies that are currently operating in the field, are really trying to move these applications forward and help us to build them fast and securely. OK, but so this is, I would even say that this is our current state of the market. So we are building these properly defined topologies where we say how the system should look like, and it tries to produce a result. But the future is, as everyone is saying, about AI agents, and AI agents are more autonomous systems, not necessarily fully autonomous systems, and I will talk about that a little bit. And I believe that the market, how it is shaping, will move to one of the two kind of sides. There will be two routes of where innovation is happening. But I will go into that into a little bit detail in a few minutes. So AI agents, very shortly, you have a core which has a large language model as a brain, and you have an orchestrator framework. It can be one of the more popular ones that I listed before, or what the Danske Bank built. And you add some additional elements that help this large language model achieve its intent in an environment. So first, you have tools. So tool can be anything. It can be a function call. You could even say that function call is enough because you can run anything through a function call. It can be an API call. It can be a database query. It can be a web search. It can be anything, literally. Then we have some planning capabilities where a LLM should be able to figure out what it needs to do to achieve its result when it's not properly defined, when the path to achieving the result is not properly defined beforehand. And then we have some memory, short and long term. And this is where just the state of the system is being held. So I have another diagram here, which I will not go too deep into it, but it is very useful to mimic agents' memory structure to be very similar to what humans' memory structure is. So we have short-term memory, we have long-term memory, and we can split long-term memory into multiple pieces. So one of them is how the agent topology is structured. Another one what data it has access to additionally tap into that if it lacks the context in what it has been trained on. Or also right here is action history that allows the agent to understand what it already has been doing recently. So I will not go too deep into this. But OK, so before that, I want to say that I believe that the future of agents will evolve in one of two ways. One, actually, it will probably happen in parallel, but one will be targeting business value, so new business cases to be solved and money to be made in the industry. And another one will be targeting, well, what we are calling AGI, so creating a digital human that can solve anything in our world. And I think there are two different paths to achieve this, but both of them, to some extent, rely on what we are currently calling reasoning models. And they are relatively hyped, I think, because they can reason and they can produce better outputs. But I wanted to dig a little bit deeper into trying to figure out how all of that fits into the agentic world, not thinking about it just as a single model that can reason. So if you have worked with large language models to some extent, so if you have been prompting at least a little bit, you probably know of a technique called chain of thought, where you have an LLM, you have a answer that you're trying to achieve, and then you prompt the large language model to produce a chain of thoughts, and then it can come to the answer in a more accurate way. And it produces it by actually printing it out, so by generating tokens in its inference time. It helps to improve the accuracy of the model. It has been proven, and it is one of the most popular. It was one of the most popular techniques to make your systems more accurate. Now, what has been happening in the industry recently with models like GPT-o1 and more recently DeepSeek R1 is that we were training models themselves to produce these chains of thoughts and produce good chains of thoughts that actually bring you to the answer that you expect. So if on a very high level, and if you're deep into this, please do not be angry with me, because I will be going relatively high level to explain what is happening here. So we have a target answer for a specific query. Then we have the reasoning or chain of thought in between. And then we prompt our LLM to produce different chains of thoughts to try and come up with an answer to your query that you have provided initially. And it will do so. It will do so continuously. It will branch at some points in time. And eventually, it will start producing answers. Some of the answers will actually fall into the expected range of answers. So it is easiest to perform this procedure on very well verifiable domains. So that's also why things like coding is already, you could say it's already being solved. It's not ideal, but it is easiest to solve because you always know what to expect from your code. So if it compiles, or if it is able to pass unit tests, or if it produces just the result that you actually expected, it is very easy to verify. And then you can very easily verify if the chain of thought that actually came up with that code produced the actual code that solved the problem. So what these reasoning models do on a very high level is we simply eliminate all of the wrong chains of thoughts from the massive amount of chains of thoughts that you actually produced. And then we take only the good ones, and we continuously fine-tune the model to try and make it produce quality chains of thoughts to continuously improve the final accuracy of the final answer. And it works. DeepSeek has proved that this pure reinforcement learning type of learning is actually possible, even though that we are providing some golden data to the fine-tuning process initially, but we have proven that it can be done even without that. And when it comes to other models, how, for example, OpenAI did it, so initially they spent a lot of time on producing these high-quality chains of thoughts that were fed into the model to actually produce this O1 model. But I think that the market will embrace what DeepSeek has kind of not uncovered, but proven to work, and we will see a lot more of these kinds of training processes. So, okay, so why am I even talking about reasoning models when it comes to agentic systems? Because it's just a model that produces reasoning chain of thoughts and gets to the answer. So, in my mind, you can think about building this into an agentic system, looking into from two perspectives. One is focusing on the reasoning, so the actual chain of thoughts that was produced to come to the final answer. And another one is to focus on the output itself. So we already know that we have good models that can reason well and produce good outputs. So if we start with focusing on the outputs, we already have an LLM which is very well fine-tuned to come up with a very, very strong chain of thought reasoning process and come up with very good answers. So we just take this LLM and then put it as a core of your agentic system. So you use it in the initial kind of stage of running your agentic system. What these models are really, really good at is producing a detailed plan of how a particular problem could be solved. And this is what we are now seeing, actually, companies doing. So what we do is that we now have this core with a reasoning model as a center of it. Then we provide the system with tools, and tools are usually other agents, sub-agents that are specifically meant to solve a smaller problem. But the core itself provides the planning capability, so it's able to come up with an ideal plan of how to solve problem. This is how code is written as well, because you can come up with a very nice structure for your repository of how you should structure the code, and then you can employ simpler models as well to produce the code, the models that are more specifically tailored to produce code. We know that Anthropic and the Cloud, the family of models, are best for this, but you can choose any kind of model in any kind of piece of your architecture. And then you share the memory. So you kind of treat your memory as a state of your system, and then each of the steps in the pipeline, so if you produce some reasoning, it updates the state with the plan of the next actions. If an action is taken by another agent, it continues to evolve the state through the memory, and eventually we come up with the final state of the memory, which is intended to solve our problem. So I played a little bit recently. Everyone is now building deep research agents. So if you would look up any open source LLM orchestration framework, you will see their own deep research agent implementation. So I also did that. This open source version of mine is coming out this Saturday, actually. So if you want to just see how the code might look like without any LLM orchestration frameworks, I will be releasing it in my Saturday's newsletter episode. So what I tried to introduce was this. So I kind of have a topic that I want researched. Then I pass it through a more sophisticated LLM, which in my case was DeepSeek R1. I actually got access to this 681 billion parameter version, but you can actually do that on smaller models as well, because we are also capable of producing really good plans. And then I asked it to produce a report plan, to structure it into paragraphs, to come up with a conclusion, so that all of these pieces have a title, the content that would be expected from this, and then you feed all of those plans for a paragraph to a next step, which is called research in this case, and ask a research step to research each paragraph and construct the final report for you. And then you have summarization mini agent, which summarizes all of it, transforms it into Markdown file. You can save it as PDF, you can save it as .md file, and it will be able to visualize the data. So each of the research step goes a little bit deeper. So you have a plan for your paragraph. Then you ask an LLM to produce a search query in the web. You perform that search query. You get some search results. You ask another LLM to reflect on those search results and produce a new search query to enrich those search results. And you continue that in the loop for some m times. So you don't need to predefine that, and you can allow your system to figure out how many steps you need to take. And it is already quite a complicated system because it runs for a minimum of 1 plus n times m plus 1 plus 1 steps. So that's how many LLM calls it involves. And I ran into quite some annoying issues because I was building it without any LLM orchestration frameworks. So first of all, the outputs in JSON, so structured outputs, for example, is a big problem if you're not using any widely adopted LLM provider. Evaluation of what is actually going on in those reflection steps is hard. Figuring out why we came up with this final state of a report is hard. So imagine you're doing something like this in production, and that would not be easy to implement without all of that pyramid that we discussed initially. So this is, but still, this is a very big area, and I think this is how the new business use cases will be solved. This is how not proper, but halfway there automation of agentic systems will happen, because we can already create a plan of actions to solve the problem without needing to define those action flows by humans. And we can do that in a high quality. The problem is that we cannot really ensure that the remaining sub-agents will not go off rails, because if, let's say, we have a system that has, not a system, but an agent that has 99% accuracy, if you have, let's say, 100 steps in the system, you can multiply that, you can raise it to a power of 100, and you'll know how accurate the system is. Usually it's not that accurate when you have so many steps. And the next path that I mentioned initially is what I call a path towards AGI. And I think, I believe, and I kind of know a little bit, that those big labs that are actually racing towards AGI, we are trying to solve this and not multi-agent frameworks. So if we would look into this reasoning part of the reasoning models, what we really want to do is allow fine-tuning tool usage into the reasoning process itself. So if I provide an agentic system, so a model which I'm fine-tuning, a registry of tools which it can source from, or even while kind of performing in this chain of thought process, create its own tools, register the tools, and use them in this process, it is possible to do. But then you need some additional technical let's say, nuances implemented in your training process. But what you can do is stop the training process at some steps, provide some tooling in the middle, and the system being able to interact in the environment might change the path to its next reasoning, next thought in the chain, because it changed the environment in some way. Maybe it performed an action via browser. Maybe it figured out new information from the web, which allowed it to enrich its own understanding of the environment, and it allowed it to kind of derail from a path that it would originally take. And then you would do that for all of the points in the path. Oh, sorry. So that's the final slide, yes. And eventually, you would create a system which is able to use tools without needing to involve additional agents in the process. So you would create one powerful model which is able to use tools in its reasoning process, and it would be fine-tuned to use specific tools in its reasoning process. This is a very hard process in general, very hard procedure to nail in general, because first of all, you can try to fine-tune it to operate in a very limited environment. So for example, you give it a computer, and then you fine-tune the system to kind of perform actions on your behalf by allowing it to operate, click on things, etc. But if you want to create something very general, the number of possibilities of how you can combine this environment explodes. And there is this kind of feeling in the air that it's still possible to expand the environment, to fine-tune the model continuously on different environments, and then some of the environments will start to regularizing to other environments that it hasn't been trained on. And I do believe that this might be one of the kind of what the top companies in AI are currently thinking of, and that's, I think, what we might be thinking when they say that we might have AGI in kind of 3 years or so. I think they are taking this approach and not the multi-agent approach. Maybe there are some agents, multiple agents in the process, but I think this is how eventually we will come up with those very expensive models that will take a lot of time to come up with an answer or an action or a desired state of your system. Yeah, and this is actually my talk. I wanted to cover this, and and that's me. So if you want to follow me, you can do that on LinkedIn. You can find me on my Substack as well. Thank you.